All right, so we want to introduce this is our objective to define and identify real numbers. So we'll be looking at natural numbers, whole numbers, integers, rational and irrational numbers, and all of these numbers together would make up the real numbers. So we have to recognize that all natural numbers belong to the group of whole numbers, which belong to the group of integers, which belong to the group of rational numbers, which belong to the group of real numbers. That's a whole mouthful. So we have integers, and those no, this isn't integers. This is rational. Q is rational numbers. So the set of the union of the rational numbers and irrational numbers together make up all the real numbers. And the intersection of rational numbers and irrational numbers is an empty set. This means that numbers have to be either rational or irrational. There's no in between. So as we would look at these time devices, as we would call them, this is an analog clock. Notice that we have the numbers from 1 going all around to 12. These are numbers on the calendar from 1 to 30. What they have in common is these are all counting numbers. Whenever we count, we always start with the number 1. Now, I do not have the rights to this video, and so I will not include it in this recording. But this is the song of the Count from Sesame Street singing how he loved to count. And so, if you so desire, I'll put this video in the description and you can click on it and listen at your convenience. But the natural numbers are the counting numbers. We start at 1, we go to 2, we go to 3. And these three dots tell us that this series of numbers goes on indefinitely. So if you so desired, you could count without stopping. And I guess I think you would give up before you reach the end because there is no end. Then we have the whole numbers. So anytime I introduce whole numbers, I always look at this cookie. Notice that the cookie is not bitten. And when it is not bitten, it is a whole cookie. And it is in the shape of a zero or the letter O, but because we're dealing with numbers, it is in the shape of a zero. So this means that when we are looking at whole numbers, we must include zero. Zero is a whole number. And then it includes all of the natural numbers. So when we say that all the natural numbers belong to the set of whole numbers, this is what we mean. We include all the counting numbers plus zero, and this makes up the set of whole numbers. So as it says here, when you look at a cookie that is not bitten, it is whole. If you bite it, it's not going to be whole anymore. And then it won't look like zero anymore either. So that's why when you start, you're looking at the whole numbers, I try to think of the cookie, which looks like the number zero. Then we have integers. Integers are what we call directed number. That means that these numbers are assigned either a positive or a negative in front of the number. It is a direction. It is not part of the number. It is a direction. So if someone is standing here in the middle and they move to the right, if they move in a positive direction, we say positive 1, positive 2, positive 3, positive 4, positive 5. It goes all the way up to positive infinity. Notice we're only using whole numbers. If we choose a negative number in between, they are no longer integers. So negative half or positive half would be it'll be a number that is positive or negative, but it is not an integer. Integers must belong to the group of whole numbers. And so if I move in the left direction, these numbers are negative. So that's negative 1, negative 2, negative 3, negative 4, negative 5. So these integers are whole numbers that have direction, and they also include zero. So zero is neither positive nor negative, or you can say it is both positive and negative, however you want to look at it. And then we have what we call rational numbers. Now, if you look at this, it says ratio, ratio. So that means that rational numbers are numbers that can be written as fractions or in the form of a ratio. It has a, if you have a numerator and a denominator and they are both whole numbers, it is rational. So they include fractions and decimals. So look at this number 3/5. There's the numerator, there's the denominator. 8/9, numerator, denominator. 0.6, which is the number 0, numerator and denominator. The number 1.25 is the number 1 1/4, which can be written as the number 5/4, where 5 is in the numerator and 4 is in the denominator. Now this number is 0.0333. So actually this is the number 333 10,000s, where 333 will be in the numerator and 10,000 will be in the denominator. As long as you can write any number in a fraction form where both the numerator and the denominator are whole numbers, it is rational. And look at the different ways you can get rational numbers. They can be positive and they can be negative. Whenever you find a number that cannot be written in the form of a fraction where the numerator and the denominator are whole numbers, that number is irrational. Obvious candidates will be the number pi. Pi cannot be written in a way that the numerator and the denominator are both whole. Anytime you do an exam and they show you a value for pi such as 22/7 or 3.142, it is an approximate value. It is not an exact value. And as you can see, this is 3.14159.265. This number is going to run on forever. The square root of prime numbers are also going to be irrational. And then there is the natural logarithm e. We don't normally see that in the BGCSE level, but that is also going to be irrational. So all of these numbers we have discussed, all of these are called real numbers. Now, when you get to college, they'll talk about numbers that are not real. They're called imaginary, but we do not teach that at this level. So the real numbers include the rational and irrational. So Q and Q prime or Q complement, n belongs to the set of whole numbers. The natural numbers are all whole. The whole numbers are all integers. The integers are all rational, and all the rational numbers are real. So the rational numbers belong to the set of real numbers. The irrational numbers belong to the set of real numbers. And there's no intersection between rational and irrational numbers. A number is either rational or irrational. It cannot be both. And so this is a Venn diagram that shows what we're looking at. Natural numbers belong to whole numbers, belong to integers, belong to rational numbers. And then the irrational numbers is outside of the circle. These two all together make up our real numbers.